All right. Here we're going to look at exceptions to the octet rule. So remember, typically for the octet rule, we're looking for each atom to have 8 electrons. Unless it's a hydrogen, then it just needs the 2. Now, how do we come up with Lewis structures? That's from adding up those valence electrons. You kind of think of it as a pot of valence electrons. Ions, if it's a negative ion, you're adding to that pot. If it's a positive ion, you're subtracting from that pot. So if we look at this first one, carbon brings 4 valence electrons. Each hydrogen brings 1 valence electron. And so we're looking at here structures. We're looking at, is it a reasonable structure? And then maybe some exceptions. What are those exceptions? Well, that's when sometimes we have ones that have less than an octet. So that would be boron usually, maybe a couple other examples. Sometimes we have more than an octet. Now remember, when we have more than octet, that has to come from something in the third group or lower. So we're looking at these ones, right? Because we're mostly looking at covalently bonded things. So we're looking at these non-metals here, and they have to have access to d orbitals. Remember, n equals 1, 2, 3. Not until 3 do we have those d orbitals. Even though they show up down here, this is those 3 d orbitals. These have access to those, and they can hybridize into that d orbital, which we'll talk about later on. And so that would be things like sulfur or bromine, iodine. They can actually be a central atom. Whereas fluorine will not be a central atom because it cannot exceed that octet. So let's look at this first one here. Notice carbon likes to typically have 4 bonds. That may be through double bonds, triple bonds, single bonds. But here we only have 3. So that's something to look at. But what we do see is we have a charge here. So the first thing we do, just like when we're drawing Lewis structures, is add up those valence electrons. We got 4 from the carbon, plus 3 from the hydrogens, but because it's positive, we lose 1. So we have a total of 6 valence electrons. Now, what do we see? We see 2 here, we see 2 here, we see 2 here. Now, the hydrogens are all happy. They have their duets. Carbon only has 6, which isn't good, but because it is charged, because it has that positive charge, that seems to be a reasonable Lewis structure due to that lack of electrons. So let's look at the next one. So we got IBr2 minus. Again, we got another charge. So that's going to add an electron. So we have I has 7 plus Br has 7, and there's 2 of them. So we got 21, and then we're going to add 1 more. So we got 22 valence electrons. So let's count them. We got 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So we're only showing 20 valence electrons. Everything has its octet. So here's 8, here's 8, here's 8, but we did not use enough valence electrons. So again, that's always what we should do first with Lewis structures is count those valence electrons and then make sure we're using enough. In a case like this, we would add an additional pair on the central atom. So there should be another, 2 here on the central atom, which changes that 3-dimensional shape. So that's important to know. Okay, let's look at the next one. So all of these have 7. Iodine has 7. Fluorines have 7. So we have 7 plus 28, and then we're going to add 1 because of this charge. So we have 36. So let's count it. We got 8 plus 8 plus 8 plus 8. So that's 32, 34, 36. So that's looking pretty good. Notice the extra ones went on the central atom, which is what we want to do. The fluorines all have an octet. Fluorine does not like to have anything but a single bond because its electronegativity is so strong. And so we got what looks like a reasonable structure here. We use the right amount of valence electrons, and we have fluorines with an octet, and we put the extra ones on the central atom. So let's check this. There we go. Okay, so first things first, count those valence electrons. Are we using the right amount? If there's extra ones, they should go on the central atom. Sometimes we have a central atom that has less than an octet, like the first example as well, which only worked because we had that positive charge. So, and don't forget to add the electrons into your pot from those ions.